Hello everyone, I'm Aaron from DataStax, and today I'm going to take you through leveraging the Table API with CQL tables. Now this is just going to be an introductory level presentation, but you're going to learn some really cool stuff doing it. So hey, pay attention and yeah, let's go. All right, so our agenda today is pretty simple. We're going to have a short discussion about the Data API, a little about the Table API, and we're going to go over some queries, and then I'll have a demo for you to kind of show how this all works. So the Data API, as I'm sure you've heard a lot about it lately, works from a document paradigm. It's essentially an application that sits on top of DataStax Enterprise, AstroDB, and it can now sit on top of open source Cassandra. This way, you can work from a document paradigm, just kind of like you would with, like other popular document-based NoSQL data stores. The idea is that data is stored in collections, and collections, while coded to work as CQL tables, are also very, very different in their behavior from CQL tables. You can work with the Data API by making RESTful requests using either Java or TypeScript or Python, and you can even use curl from the command line if you want to as well. All in all, this makes it so that if you have a document problem that you need to solve, you can still do it with a Cassandra-based database. So now we have the Table API. So now this lets you work from a document paradigm with underlying Cassandra storage. So the difference here is that the Table API stores data in CQL tables. And those CQL tables are not any different from the CQL tables that you know and love and have been using for years. It works with the same clients. In fact, it is essentially the same client. The newer versions of the Data API will have objects in it that expose the Table API. Essentially, it's RESTful calls that are made to that API are ultimately converted into CQL, and it requires no changes to the table whatsoever. Aaron Morton talked about this a lot at Cassandra Forward, and his main thing was that we still have a CQL core, and that's not going away. But in this way, we can work with CQL tables from a document paradigm. So it's kind of cool how this how this can evolve. All right, so what do our queries look like? Well, if we have a your traditional like CQL insert that you've been working with, so we can say, hey, insert into my table. We have these columns and insert like these values or these placeholders if you're inside of some code and using a prepared statement. This is how you'd typically do it. Well, with the Table API, you can go ahead and define, for Java anyway, a new row object. You can add each of the columns and their values to that row object, and then you go ahead and insert that row. And in our case, we're doing a weather data table.insert one. So we know that we're just taking the one row and then we're inserting that into our table. Of course, a straight up query that you've seen in CQL looks kind of like this. Select star from my table where ID equals, and whatever placeholder you have to inject your value. On the Table API side, it's very, very similar, nigh identical to how we work with the Data API, where we define our filter and we set it up. In this case, we're using a where method and then sending in is equals to method along with it to, kind of chain them together. And then we're getting the row back as a result. And that way we can work with it and, pull off its individual values that we need and build them into our application. So this is pretty slick how this works. All right, now for a short demonstration, we're essentially going to create a table, insert some rows, read a row, and then we'll actually have a look inside the database just to see how this is all represented. So starting out here in my IDE, you can see that I have a Maven Java project, and I've gone ahead and kind of defined that out. but I also have a dependency here for the DataStax Data API Java client. And you'll notice that I specified the version number as 2.0.0-preview1. Right now, the table API is still under development. It's still in like kind of a alpha-ish, beta-ish kind of a mode. So it really is only available currently inside of the preview version of the Java client. So you got to keep that in mind. What we're going to do is, let's say that we have a, we're keeping track of weather data. So I have a weather data POJO here that, has all of my class properties. I have a toString method that overrides the delivered to string. And then I have getter and setter assessor methods that pull that all back. If I have a look inside of my main program here, you can see that I'm pulling in my AsterDB token. I'm using my AsterDB API endpoint as well that you can get from your Aster dashboard by your database. Similarly, just like you would with the data API, you define the client, you go ahead and get your database and specify your key space as well. And similar to what we use for a lot of the examples with the data API, I'm going to stick with the default key space. Now we go ahead and create a table. So we can do that from within the code. Let's say that I have this new table definition object. So I'm going to define that as new. I'm going to have some table options for create that I want as well. And I'm also going to define my primary key. So those of you who have worked with CQL for a while before kind of know all these different things that normally go into table creation. We kind of have listed out here in an object-oriented fashion. So I go ahead and I define my primary key. So let's say that I want, a composite partition key of station ID and month bucket, and then I add those to a list, and I set that as my partition key. And then I create a hash map for my clustering keys, and I put in reading timestamp as my clustering key, and then -1 for descending order. And then I also go ahead and add that as a partition sort, and that's all part of the primary key. And then I can set that primary key on the table definition. Here's where I go ahead and define all of my columns. You see we have add column text, int, timestamp, just regular columns if you wanted to add things that don't line up in there. Like we don't have a special one for floating point types right now. But like I said, we're in kind of like an alpha beta-ish kind of a mode, so that's all coming. Maps work as long as you're working with maps that are all strings, so text, comma, text index, text value, that is. And of course, we'll also set a table creation option of if not exists, true. So we're not always going to try to create the table. We're only going to create it if it doesn't exist. So here's where we go. We pass the DB API. We hit the create table method with the name of our table definition above, and then our options of, if not exists, true. Let's go ahead and try that out. All right, our breakpoint has taken us to this create table command. I'm just going to step through that. There we go. All right, we've made it through. So now if I head out to AsterDB, let's see, we can go into VectorDB. Notice right here inside of my database dashboard on my actual VectorDB database, here is where I can get my endpoint from, and here is where I can generate a new token. So all of the credentials that you need for the data API and by proxy the table API can all be found inside your Aster dashboard very easily. Since this is a CQL table, I can't look at it with the Data Explorer, so I'm going to fire up a CQL console. All right, so let's use our default key space, and let's describe table weather by station by month. All right. Well, there is the table that we just created. So you'll notice that we have our cloud cover here. It's a text. Let's see. You notice our primary key came through just as we built it with station ID and month bucket as the partitioning key, and then reading timestamp as our clustering key, and then here is our clustering order, reading timestamp in descending order. So this is all great. So if I say select star from weather by station by month, well, there's nothing in there just yet because we just created the table. So let's jump back over to our Java code for a second. You'll notice I'm creating a new weather data record here. 2 of them, actually. And yep, then we're setting like our, these are weather data readings. So we're setting like our, our values up here, and then building the cloud cover map here and here. And then we insert these into the table. So why don't I go ahead and make sure that I have a breakpoint there, and let's run through there. All right, so we stop at insert 1, stop at the next insert 1. Okay, so we've inserted. Let's go ahead and rerun our select. Bam. We have 2 weather readings out there. So as you can see, our code actually did manage to put this out in a CQL table format. All right, well, how about querying? So if we go ahead and we build our queries similar to how I described, so we have our filter, we have, where station ID is equal to station ID. We're also going to have another where clause in there of month bucket equals to month bucket. And that goes back up to these values that I defined. So we're going to pull back things for the weather station of KMSP and a month bucket of 2025-03. And then we're just going to do a find one. So there are 2 rows out there. It's going to pull one of them back. I assume if we're going by our clustering key, it'll pull back the most recent entry. And then it checks if, our result has a row inside of it. And if it does, it maps it back to a weather data object and prints it out. So let's see if this works. All right, there we go. So it did in fact pull a record back. 2025-03-12. And yep, we have our cloud cover, we have our temperature of 0.6 degrees Celsius. Let's jump back here a second. And if I look at my timestamps, I have 2025-03-12 and 2025-03-7. So it did in fact pull back the most recent reading. So hey, this works. This is a simple example of how you can use the table API to work with your existing CQL tables from a document paradigm. All right, of course, feel free to check out DataStax' documentation. We have quite a bit out there around the data API. You can find this documentation out at datastax.com en astra-db-serverless API-reference. And then our data API docs are at data API client HTML. And then the table API is table-methods/create table.html. That'll kind of take you through from the beginning of creating a table and then actually working with it, from that document perspective. All right, I hope you enjoyed this short video. Thanks for listening in, and hey, if you have a sec, check out the table API. It's definitely pretty cool, and it can definitely help you if you have a documented-oriented application or application approach that may need to use an existing CQL table. Thank you very much, and have a great day. Want more information on modernizing your self-managed Cassandra deployments? Head on out to datastax.com/modernize-apache-cassandra-workloads, and you'll find all the information you need on keeping your self-managed Cassandra cluster updated and in top running form. Thank you, and have a great day.